Hi everyone. Today we are going to present about thermal behavior and phase transition of lamellar liquid crystal in cosmetic formulation, a DSC and TGA study. For the principle of thermal analysis is a tool used to study how the physical and chemical properties of material change with temperature. It is widely applied to complex systems like lamellar liquid crystal, which are alternating hydrophilic and hydrophobic layer of surfactant and oil. So the technique we use are the thermogravimetric analysis (TGA). TGA monitor the weight of sample as a function of temperature. This provides critical information regarding water loss, the decomposition of organic components, and the overall thermal stability of the substance. The second technique is a differential scanning calorimeter (DSC). This technique measures the heat flow into or out of a sample as it heated or cooled. It allowed for the detection of endothermic and exothermic events such as melting, crystallization, or structural reorganization within the material. For the type of industry chosen, the cosmetic industry was chosen for this study because lamellar liquid crystals are widely applied in high-end skincare and cosmetic products like moisturizer and lotion. It is highly competitive sector where product performance, stability, and consumer perception are crucial. For the importance of thermal analysis in the cosmetic industry, for the structural integrity, temperature change can induce phase transitions such as the melting of the lamellar layer, which can significantly affect product performance, viscosity, and the consumer's experience. For the manufacturing guidance, DSC data inform manufacturers of the temperature limit during production, such as mixing, homogenization, or heat-assist emulsification to avoid the breakdown of the lamellar structure. For the shelf life and reliability, TGA ensure that products maintain the hydration properties and the structural integrity over time, which directly impacts consumer satisfaction. For the name of analyte or compound, primary surfactant, sodium dodecyl sulfate (SDS), which reduce interfacial tension to facilitate layer information. For core surfactant, fatty alcohol like hexadecanol, cetyl alcohol, and octadecanol cetyl alcohol, which strengthen the lamellar network and improve layer rigidity. For the shelf life and reliability, TGA ensure that the product maintain the hydration property and structural integrity over time, which directly impact consumer satisfaction.
Proper sample preparation is critical. For TGA, samples are weighed and placed in a crucible. It often varies to incubate them at room temperature. First, to ensure consistent starting conditions. For DSC, we need precision. Samples of 5 to 10 milligrams are weighed and placed in sealed aluminum pans. Sealing is vital here to prevent moisture evaporation, ensuring that the heat flow readings reflect actual structural transition rather than just water loss. For both techniques, homogenization is key. The lamellar cream must be gently homogenized to ensure surfactants and oils are uniformly distributed for reproducible results. Why do we use these specific techniques? TGA is excellent for quantitative data on water content and identifying exact decomposition temperatures. DSC, on the other hand, offers high sensitivity to subtle phase change, such as the gel to liquid transition, which involve no mass load and will be missed by TGA. However, there are disadvantages. TGA is effectively blind to melting or crystallization events because these processes don't change the sample weight. The SC results can be highly sensitive to how well the pan is sealed, and it can sometimes be difficult to distinguish between simple evaporation and a chemical change. Let's examine the procedures for thermogravimetric analysis, or TGA. The temperature program is designed to show mass loss. We typically observe a 5 to 15% loss due to water evaporation and a 20 to 40% loss from surfactant decomposition. The flow rate uses a precisely controlled flow of inert gas, like nitrogen. This ensures that any mass change detected occurs solely by thermal effect, not environmental reactions. The radiation source applies thermal energy to induce wave change as the temperature increases, allowing us to observe moisture loss and decomposition. Let's look at the operating procedure for differential scanning calorimetry, or DSC. First, the temperature program. The system is set to show endothermic peak. Specifically, we look for transition between 45 to 55 degrees Celsius, indicating a gel to lamellar transition, and 75 to 90 degrees Celsius for the transition to an isotropic liquid. Next, the flow rate. Analysis is always conducted under a controlled atmosphere, typically using nitrogen gas. This ensures a stable heat flow and crucially prevents sample oxidation during the heating process. Finally, the radiation source. The SC measures heat flow by applying controlled thermal energy. This allows us to detect both endothermic and exothermic events within the sample. Here is what the data tell us. The TGS spectrum reveals thermal stability through wet loss stage. We see an initial drop of 5 to 15% between 30 and 120 degrees Celsius, caused by the evaporation of free water between surfactant layers. A second major drop between 200 and 350 degrees indicates the chemical decomposition of acetyl and stearyl alcohols. The DSC thermogram displays two distinct endothermic peaks. First, between 45 and 55 degrees signify the transition from a rigid gel to a lamellar liquid crystal phase. The second peak, between 75 and 90 degrees, shows the final breakdown into an isotropic liquid. Finally, we must consider the limitations. TGA is limited to detecting change involving mass. If a cosmetic product separates into oil and water without evaporating, TGA will show a flat line, missing the fact that the product is spot. DSC cannot provide structural information. It tells you a change happened, but not what the structure looked like. To confirm a structure is lamellar, for instance, DSC must be paired with X-ray diffraction. That's all from us. Thank you.